Hey guys, my name is Lee. Today we're going to tell you about four-dimensional tic-tac-toe.
Hey guys, today we're going to tell you about the four-dimensional tic-tac-toe. Let's first talk about the history of the tic-tac-toe. The earliest version of this game was played in the Roman Empire around the 1st century BC. The game's grave markings were found upon ancient Roman ruins using chalks and pebbles. Variation of the game continued to develop as time went on. The British name of this game, Nuts and Crosses, appeared in 1864.
The game continued to advance with versions including more complex board sizes and using different variations of rules. Fast forward to modern day, we have developed multi-dimensional versions of tic-tac-toe. We are all very familiar growing up playing the classic 3x3 version. Unlike regular two-dimensional tic-tac-toe, the game becomes more complicated as more dimensions are added. By observing this game in third and fourth dimensions, we are able to evaluate strategies and outcomes in a more advanced approach.
To begin, let's review the version we are familiar with. In the two-dimensional version, we have a board created by a 3x3 grid of squares. The goal of this game is to be the first player to get 3 in a row on the 3x3 grid. The player who's playing X will always go first. Two players alternate placing X's and O's on the game board until one of the players has 3 X's or 3 O's in a row, horizontally, vertically, or diagonally. The first player chooses among 9 squares, and the second player chooses among 8, and so on. Therefore, the total number of games is 9 factorial, which equals 362,880. In this version, it is fairly simple to force a draw upon the other player, but if both players are playing optimally, where both are always making the best possible move, the game will always result in a draw. In this case, the only way a player can force a win is if their opponent makes a mistake. In a finite two-player game, either the first player can force a win, the second player can force a win, or each player can force a draw. The Q-player positional game consists of a set of points, a set of lines, which are the subset of P. Q players who take turns choosing unchosen points from P until either a player has chosen all the points in any line and therefore that player wins, or all the points in P are chosen and the players draw. In a positional game, the second player can't force a win, leaving the two options of either the first player forcing a win or the second player forcing a draw.
game of tic-tac-toe in the third dimension is very similar to the version we're used to. Instead of one grid with 9 squares, picture 3 grids of 9 squares stacked on top of each other. In other words, you can essentially picture the structure of Rubik's Cube. As usual, the diagonal, horizontal, and vertical set of 3 will allow you to win, but because of the third dimensional factor, there are more winning strategies. Similar to the classic version, in the cubic 2-player game, a player can essentially force a win. However, in this dimension, the center cell plays a pivotal role. The player who uses the center cell will always win, and the game will never be a draw. By banning the use of the center cell, the game can still be won by the first player.
The model we are playing on is a 3-dimensional tic-tac-toe that is 4x4x4, which is 3D printed. As you can see, this model is basically a 2D version of a 4x4x4 model, stacked upon itself 4 times. It's very hard to visualize the 4th dimension because we don't live in a 4th dimensional space. However, there's a way to simulate it alongside some imagination. We want to create a tic-tac-toe board of a 4x4x4x4 grid. To begin, imagine a 4x4 grid. We want 4x4 of the 4x4 grid like that one shown.
In the previous stage, we looked at X, Y, and Z axes. Let's call the 4th dimension the W axis. For each grid, we have horizontal x-axis and vertical y-axis. Among the 16 grids, we call the horizontal axis the z-axis. In every row, there are 4 4x4 grids, and we can layer them to make the 3D tic-tac-toe, just like the model we showed earlier. Then, to add one more dimension, we add the vertical w-axis. Each square in this game is labeled with D coordinates, which are numbers between 1 and W. On this board, a win of 4 in a row is achieved if 4 marks are in a straight line on any cube that can be formed by assembling 4 squares in a serial order along any orthogonal diagonal or either of the 2 main diagonals. Any set of W boxes makes a line if each coordinate is the same for all 4 boxes, different for every box and increasing, or different for every box and decreasing. This rule also applies for the 3D and 2D versions of the game. As dimensions increase, there are more directions and lines that can complex it further than the 2D version. Along with more lines of the board comes with more winning lines, allowing more chances for a player to win the game as dimensions increase, and less likely for a draw. Thank you for watching our video, and we hope you learned something about tic-tac-toe in multi-dimensions.